Our next speaker is Jack Gibbons. Jack is semi-retired after 45 years in the concrete industry, primarily in tech services in the ready-mixed industry. He was designated Influencer of the Year in 2011 by Concrete Construction Magazine. In 2013, he was presented with the Richard Staley Industry Advancement Award by the Minnesota Concrete Council. He's been published in Structure, Concrete Contractor, Concrete International, and Concrete Construction. He's a longtime member of several ACI committees and is a fellow of the ACI. Jack is going to be presenting on pumping for the Trump, Aqua, and Coast Towers in Chicago. Go ahead, Jack.
But anyway, you might recognize this from Eamon's earlier presentation. This is the Aqua Tower in Chicago, 85-story building, 9 miles of balcony edge, and no two balconies in the building are the same size or dimension. This is a fun project to work on. As you can see, it's got some crazy dimensions. This is the 56th floor. As you can see by looking at this, relatively fluid mix. I'm not even sure what kind of slumps they were getting, but coming out of the pump, I would say that's pretty easily an 8-inch slump. And the thing you want to focus on, this slide and a lot of the others you'll be seeing, is the beautiful distribution of coarse aggregate held very nicely in suspension. This is the roof deck of Aqua, the 85th floor. I don't know if it's going quite nicely without the aid of a vibrator. And again, you can see a very cohesive looking mix design. Now, the reason it's important pump pressure, a little on the high side, but still pretty acceptable considering 85 floors with that level of mix. Pump operator doesn't get too concerned until that needle starts hitting 300, and then he gets very, very concerned. But again, the pump is hands down the best application here because there are other methods for placing concrete, not nearly as efficient. And I want to add, this is not a McHugh project, by the way. This is one of their competitors. And it's not in downtown Chicago, it's out in the suburbs. And again, we can even get as basic as going back to the old PCA 321 mix. You can do it that way, not very efficient. This is the Coast, another McHugh project downtown, 50-story post-tension building. As you can see, concrete flowing through Grizzly without any buildup on the Grizzly. This, I believe, is around the 30-inch floor. Beautiful shoulder on the concrete, very robust mix, beautiful distribution of coarse aggregate. And of course, coarse aggregate is the single most important ingredient in concrete, and it's not held in suspension, uniformly distributed in the concrete. We do have a vibrator down the top. That's only because of medium work rules. That does not need a lot of vibrators. And even though he's not vibrating particularly properly, he's not causing any degradation. Again, because it's a very robust mix. What makes this project unique is not only is it a very fluid mix, it's going to be tensioned in approximately 20 hours. So that's 3,000 PSI, 20 hours. Very rapid cycle. I threw this one in. It's not on the schedule. It's Roosevelt Tower, another McHugh project. Not a particularly unique building in my estimation because it's a steel frame. But we used We're getting to Trump Tower. And again, this is you might recognize this from Gibbons' presentation. It's a quote from Stan Carista, who is Director of Engineering at Skidmore. I've known Stan for many, many years. Had a lot of fun working with him on the Trump Tower project. And this quote was actually in an article, I believe it was an Engineering News Record. There were many, many articles about the Trump Tower project. And again, he references what's made the difference of concrete is the concrete mixes, the incredible efficiency of the pumps and the placing booms, and the forming systems. The only thing I would amend to this is that it's not so much the development of high strength, very, very critical in a project like Trump where we had 16,000 PSI, but just high performance mixes in general. So I actually called Stan when I saw this and said, do you mind if I use this in presentations? And he very graciously said, by all means. So why is all this important? Here you can see when we got past the final mechanical floor, which is I think around level 50, we went to a 3-day cycle per deck. So that's very, very fast. You can see the other problems associated with this. This is one of the outriggers. They were 17 foot tall and 4 some odd feet wide with a little bit of rebar. So this again is a whole other dimension of this type of work where the mix and the pump have to be extremely well coordinated. Again, a little bit of rebar in here. In this particular case, we had to go because of the rebar congestion to a 1/2 inch aggregate. And of course, without the couplers there, very, very difficult to do. End anchors, very, very important. That's the mix that we placed. That's the pump that we used, and Eamon might be able to double check this, but I believe this was a 680 horsepower pump. So very, very powerful. And no point in having a pump like that if you don't have a real high performance, high horsepower mix design. The boom operator, you can see them in the center there up on the deck. The guy was incredible. He could put concrete in your pocket. He was so good with the joystick. Very, very efficient, very quick. Again, pouring that one of the outriggers. I want to point out again, you have no problem seeing the coarse aggregate. It's easy to make fluid concrete. It's not so easy to make fluid concrete that holds that coarse aggregate uniform suspension like that, and also to be able to pump it into high-rise construction. point out here, again, beautiful looking mix. And this is actually the last pour that I physically attended at Trump Tower. This is the 88th floor, and that is a 12,000 PSI mix. So the art of the possible. Pete Alexander was Senior Vice President McHugh at the time, and he was quoted in one of the trade journals as to how this project was a technical challenge. It would have been impossible only 10 years earlier. I would have said 5 years earlier. And then you get to the crux of why all this is so important, all the speed and efficiency, because this is what the developers demand. They want speed. Speed is everything. Without speed, it just doesn't happen. It can't be successful. In this case, Donald Trump, quality and speed, and it's common knowledge that virtually every building Trump's been involved in was reinforced concrete. So, a little bit abbreviated, but any questions?
Jack, based on your experience, have you seen significant changes in concrete properties due to the pumping operation?
I'm not sure what you mean by concrete properties.
Fresh, hardened, because, you know, the concrete going in and the concrete coming out is not the same thing, or is that not a concern?
Well, we actually did not see really huge reductions in workability from the hopper to the discharge. Very, very consistent. What I certainly learned on these projects was what Walt referred to, is it's absolutely critical that you monitor your aggregates, not just throughout the project, throughout the pour. It was very interesting, like in Chicago, we have a blend of manufactured and natural sand. It's probably about a 70-30 blend. And if that gets a little high on the manufactured side, the FM starts getting up in that 285 range, you're going to have a very difficult time pumping these mixes and holding them together without segregation. So it's really critical. In fact, the weak link in the concrete industry, in my opinion, is the aggregate supplier. I don't think their level of quality control is very good. And so it's contingent on the ready mix producer to monitor the aggregates, because the aggregate supplier does not.
Jack, I got a question that came in through the chat. Is there any reduction in air content in pumping concrete in the Aqua building balconies?
Well, we didn't have a problem, and Aqua was the only one that had any air in it, and that was just for the balconies. And obviously they were pumped separately, and I am not aware of any issues. And I was head of tech services, so if there were a problem, I'm sure I would have heard about it. McHugh is not bashful about voicing their concerns.
Any other questions? Feel free to type question and answer box or the chat. We'll get them both. Jack, maybe another one. We asked a question to Eamon about what's the biggest challenge, and he mentioned the concrete. So you, as a former concrete quality control manager, do you agree with Eamon, or do you want to blame somebody else?
That's all Eamon's fault. No, he's absolutely right. The issue is, and this is where I kind of take the whole ready mix industry to task, the ready mix industry does not have enough highly skilled, trained troubleshooters. And you have to understand, a project like any of the ones that I've profiled here, we had our best people at the plant monitoring loads before they left, at the pump, and on the deck. And often throughout these projects, I was one of those three. And so we had very, very tight quality control. And on a large pour, we would actually be monitoring the FM of the sand 2 or 3 times during a pour. So we were keeping a very, very close eye on things. So it's really, when I say this is the art of the possible, that's only if you have very, very strict protocols in place.
Thank you, Jack. Again, virtual applause over here. You can't hear it, I know, but thank you for your presentation.